Fine, I'm going to talk about 86. At least set it up. Talk about 92 here. So for 86, I'm looking at the picture, and what do we got over here on the right? We got this big tower. All right, here's my big tower. Here's my little building. This is 50 feet, and we got angled elevations here and here. So now that's the building. You just got the 50 feet is going to apply to that side as well. And I think we got 41 is this angle right here, right? It's 41. Well, we can find the whole angle just by adding 90. So if you add 41 and 90, you should get 131 for right here. So that's going to be 131. And then what other factor they give us? This is 53 here. So what does this interior angle have to be? 37, right? So this is 37. Our final goal is to find that height. We can't find it directly. We cannot come up with in one step to find that. What you need to find is this length right there. And then once you find that length, you got a right triangle, you got that 53-degree angle. Well, to find that length, we can use this triangle here. All right. It's obviously not a right triangle, but that doesn't matter. We can use the law of sines. We got 37. We got 131. We got 50. What's this smaller angle going to be then? 12? Is that right? So this is 12. And let's see here. And I need that 12 degrees. So I can do sine of 12 over 50 equals sine of 131 over x. And then solving that. Now, that's not our final answer. But what, anybody have that? 181.5. So that value is 181.5. Let me change this to y. Whoops. And now from there, sine of 53 equals y over x, which is 181.5. And then that better be 145. And I think it's 144.9. Several people rounded that. It's at nearest foot, so 145. So that's how you do 86. So you're going to have to find that length and then figure out the second piece. All right, 92. And a lot of 92 is being able to draw it out. And so hopefully, on the answer key, that'll help you a little bit. Whenever you're near water, you're looking for a lighthouse or a beacon. And you want to find out how far away you are. I understand. So for this one here, I think this is north 55 degrees east. And it says this beacon is 23 miles from this dock. The boat is going to travel due east. So this is the path of the boat right there. When it is 18 miles from the beacon, what time is it? What you got to find is this distance right there. You'll find that length. And then from there, you can figure out the time. So we got to figure out that length. Well, how can I figure that out with the given information? Well, this is 55, so this is 35. At this point, I cannot find x directly because I need to know this angle. I don't know this angle, so I can't take it away from 180, but I can find this angle using law of sines. So set this up as, now this is what type of triangle? Side angle. Let me go back one second. This triangle here is angle, side, or angle, side, angle. There's only one option for this one. You cannot get two options. You only get two options for side, angle. That's why you end up getting two answers, and I'll show you the second one in a minute. But I take sine of 35 over, bless you, 18 equals sine of, I'll call this y. Sine of y over 23. So that's going to give me that bottom angle. What do you get for that? Alex, what do you got there?
47.1.
This is 47.1 degrees. So this is 47.1. Y equals 47.1. And I believe we then get 97.9.
Yeah.
97.9. All right, now at this point I can find x. Now if you found x, that's good. X should be 31.1 miles. Okay, if you got that, that's pretty good. So sine of 97.9 over x equals, I'm going to use the 35. Sine of 35 over 18, and let's see, 18 times sine of 97.9 divided by sine of 35. So it rounds to 31.1. Now they do add an extra layer here because they want to know what time will it get there or be. So you found that distance. You got to take 31.1 divided by the speed, which is 15 miles per hour. Okay, so you get that number of hours, so 2 hours. And all I would do is I'd subtract 2, take the decimal, and times that by what? To get the number of minutes. Times 60. And then that gives me 4 minutes. So that's where they get 2 hours and 4 minutes, and they get 5:04 for that time. But there is a second time that it hits. And actually, if you think about it here, it's going to be the earlier than later. So if you flip that 18 to this side, this is 47.1. We already figured this out to be 35. What's that angle there going to be? Okay, or how do we find it? Okay, how do I find it? Esther, do you remember? Are you with us here? Not really? All right, we're in pre-calc. All right. So Jackson, I'm sure you know. You've been paying attention back there, haven't you? All right, so how do I find that angle?
47.1 from 180.
Yep, you take 180 minus 47.1. Okay, what is that, 152.9? And then from there, you can figure out this angle, and then you do the same thing on the other side, and you get this distance right there to be, I believe, 6.6. And then you can divide that by 15 and figure out how many minutes. Okay, for that one. All right, make sure you're getting those other ones right. I at least wanted to talk about 86 and 92. All right, I'm going to give you guided notes here in 1 second. But first, take a look at this, draw this out, and take a look how you would solve that.
Let's go, bro.
All right, so if you draw this out, and then C is 35 degrees, and it doesn't really matter which one you label A or B. B will be 20, A is 32. This is not side-side angle. You would call that side angle side. All right, can you come up with the missing side or either missing angles at this point?
No.
No, you cannot use the law of sines. No matter how you try to set it up, you do not have enough information. Okay, so if doesn't matter what you try to do, law of sines won't work. So what do? We create the law of cosine. So for this triangle, you cannot solve it. You're stuck.
Yay.
So we got to come up with something that works. It's the law of cosine. Let me hand you that. So from here on out, it'll be on guided. No, we're not actually going to solve it. That was
Just a waste, right?
that was just a hook. That was just to get you interested.
Alright, now, so uninterested.
I wanted to solve it.
I mean, I feel like teachers have like,
I really got it.
like fun hooks until we get to the lesson. Mrs. Casey's like this, every week she has a riddle. I think get the riddle and get candy, but it's only the first two people in the class that get candy. So I'm always the third person to get the riddle. I'm the third person to get the riddle like 6 times.
Okay,
I love the last one. It was, what two-syllable name starts with the letter E, boy's name. First letter E can be rearranged to another two-syllable name, it's a girl's name. I did Ernie and Irene. And also, Elvin and Lyndon. But Lyndon's not exactly a common girl's name. It exists. Actually, so does Edward and Renee. I did that one. Sorry, I'm not Edward. I did Ernest and Renee, but Renee, the E has an accent over it. And and then there's also Edwin and Wendy. Yeah, that doesn't I would have never been able to. There's some bad ones. Real tough, but sure. Okay.
All right, so you just saw in that case there, side angle side will not work with law of sines. And so what we're going to do is come up with the law of cosines or use it. We're not going to derive it today. But it comes in these different forms. They're all the same, and you really don't, you're not going to memorize all of them. You're just going to memorize the basic pattern is if you know two sides and the angle between, you can find the side across from it, across from the angle. So if I go backwards here for a second, you can find side C. Okay, you can find that. And then from there, we can find the others. Now, I do want to go over here if you want to find an angle. So I'm just going to start with this first one. And really, you can just pay attention here. A squared equals B squared plus C squared minus 2BC cosine of A. Whatever you're solving for, A squared, that has to be the same angle. All right, how do I get cosine of A by itself? All I want to do is rearrange the formula. There's a couple of different ways, but what I'm going to do is I'm going to add, this is all one term, I'm going to add 2BC cosine A to both sides. I'm going to do plus 2BC cosine of A plus 2BC cosine of A. So I got A squared plus 2BC cosine of A equals B squared plus C squared. Got that? Well, what do I got to do on that left-hand side? I got to subtract what? A squared. So subtract A squared. I'm just going to do that here. 2BC cosine of A equals B squared plus C squared minus, that's a minus, A squared. And what's the last step I got to do to get the cosine A by itself? Divide by the 2BC. So divide by that. Divide by 2BC, and I get cosine of A equals B squared plus C squared minus A squared over 2BC. All right, go ahead and put that under cosine of A, or cosine of A. So a lot of times if you're looking for the angle, you can start with the original one, but then you got to do all that work in here. It's a little bit easier if you start here with this equation. So cosine of A equals B squared plus C squared minus A squared divided by 2BC. All right, follow the pattern. What's cosine of B going to be? I'm not going to go through all that work again. Just use the example above there. Here's the key thing you're looking at. If you're looking for angle A, you're subtracting A squared. Okay, and then you got your other two sides here. So if I'm looking for angle B, it's going to be A squared plus C squared minus B squared over 2AC. And then how about cosine C? Should be able to fill that in. It's going to be A squared plus B squared minus C squared all over 2AB. All right. So those are your forms. All right, now let's actually take a case and make sure we solve it. Two key things. The first one, you don't have any option to do. That's the only thing you can solve for. The second one, you've really got to be careful, and I'll explain why in a minute. Change your A of 24, if you would. You got 14, I believe. Change it to 24. All right, draw the figure. I got it laid out like this, and actually, let me see something. I'm just gonna. We'll slide that just a little bit further down. Make it a little bit closer to what the dimensions are. So C is 55 degrees. A is 24. And B is 9. Okay, so what we are missing is side C and the two angles. All right, when you have this situation, the only thing you can find is the side across. Okay. And so since I'm looking for C, C squared equals A squared plus B squared minus 2AB cosine of C. It's always going to be the two sides you have and the angle you have over there. So, I mean, it's not like, I don't really think you need to memorize the formula. But you got to memorize the patterns. Side squared plus side squared minus 2, side times side, cosine of the angle. All right, now plug it in, use your calculator, make sure you take the square root. That's the biggest thing you need to do is take the square root. Or people forget to do that. So C squared equals A squared, which is 9 squared, plus 24 squared minus 2 times 9 times 24 cosine 55 degrees. Mason, let me know what you get when you're done.
Yeah, I was just gonna do something.
I got 20.2.
20.2. All right, I think that's right. We agree? You gotta make sure you take the square root.
400 room.
Take the square root. So you gotta do 9 squared plus 24 squared minus 2 times 9 times 24 cosine 55. And then square root. Okay. All right, now with the directions, what does step 2 tell us to do? Find the what? Smaller of the two right angles using law of sine. Find that using law of sine. So which one is smaller? Is it going to be A or is it going to be B? It's got to be B because that's the smaller side. So use law of sine. You could technically use law of cosine, but this law of cosine is not as nice. So I'm going to take sine of B over 9 equals, I got to use the 55 degrees and I got to use the length I got for C, equals the sine of 55 degrees over 20.2. All All right, after you do that, you take your inverse sine, Caden. Let me know what you get for the angle.
21.4.
21.4, we agree, I need a second. All right, 21.4. So what does that give me for angle A? Angle A is going to equal 180 minus 55 minus 21.4. So angle A equals 180 minus 55. 103.6, 103.6 degrees. All right, so we're good here. Now I want to go through the reasoning here. It's why do you need to solve for the smaller of the two remaining angles? Okay, let me explain that. Let's say after you found the 20.2, go ahead and find, how would I set up using the law of sines to find angle A? Actually, I'm going to actually do this. So to find angle A, I would take sine of A over 24 equals sine of 55 over 20.2. Do that, see what you get for angle A. See what you get for angle A. Now,
76.7.
76.7, do we agree?
Yeah.
All right, that is wrong. That is wrong, right? Because we already figured out what angle A is. Angle A is what? 103.6. So if you found that as 76.7, you find angle B is 21.4, that's 55. They don't even add up to 180. Your calculator is going to do that. It's always going to give you that wrong answer in this situation. Now, can you tell me why? Okay, this is where you got to be smarter than your calculator. That answer is incorrect, and you got to understand why so that you don't do that. There's a reason you find the smaller angle. Anybody know? Why did it give me the wrong answer? Or why didn't it give me 103.6? Come on, Alex, you gotta have it.
I don't know.
All right. Okay, when you do inverse sine on your calculator, okay, if you do inverse sine of 0.5, well, what is that? We should know it. What's it gonna give us? It's gonna give us 30. Is there another angle that it also has a sine of 1/2? Where is the other angle that has a sine of 1/2? 150. So it's 30 and 150. Will inverse sine ever give me an angle bigger than 90? No, because inverse sine, we restricted the domain of the original function so that when we come back, when we use inverse, we only get one answer. When you do inverse sine, it gives you answers in quadrant 1 or what other quadrant? 4. It will never give you an obtuse angle. Okay, basically it gives you the supplement. Okay, if we want it to be 103 degrees, it gives us 180 minus that. So you cannot find an obtuse angle using the law of sines. It will never work. It will always give you back an angle in quadrant 1. So if you find the smaller angle first, you're guaranteed it's acute, and it will always work for the acute angle. You can't have two angles bigger than 90 degrees in a triangle. If you just randomly find an angle, you could end up getting the whole thing wrong. So you always got to find the smaller one because you cannot use the law of sines to find an obtuse angle, and you don't know which one's obtuse or not. It may not be, but it could be. So just be careful there. So the law of sines cannot find an obtuse angle. The law of sines cannot find Now, if you don't want to worry about that, then you can use the law of cosines, and I'll show you how to do that to find an angle. But it's just messier. All right, let's take a look at that second one here. Again, so you don't make this type of mistake, there's two things you need to follow. It says when using the law of cosine to solve a side triangle, okay, use the law of cosine to find the largest angle. Okay, because it could be bigger than 90 degrees, and the cosine will give you back an angle bigger than 90 degrees. So take a look at this one here. So we got triangle ABC, draw that out. Which side or which angle is going to be the biggest? Okay, Ian Kelsey, which angle will be the biggest? Angle A, this is across from the 12. So now if you want to use the formula from up above, but basically here's what's going on. Whichever angle you're looking for, cosine of A, you take the two sides that are not across from it, b squared plus c squared, minus the side that is across from it, times 2bc. Now this one, I don't always just type the whole thing in. I'll do it, the numerator first and then the denominator, because what do we get for, is it 5 and 9? 5 squared plus 9 squared minus 12 squared over 2 times 5 times 9. So I get cosine of A equals. Now, top, I get 25 plus 81. 25 plus 81 minus 144. And I get negative 38. That's okay. And then in the denominator, I get 90. All right, take the inverse cosine of that. Inverse cosine of that. And you can get a obtuse angle. That's why we want to use law of cosines for the largest one. Angle A, Lizzie, what'd you end up with?
113.9.
All right, let's work on rounding skills.
115.0.
There we go. 115, because you take a look at the number before that 9 and it moves it up. So 115.0. So that's what it's going to be for that one. Now, it really doesn't matter which one you find, because can either one of those other angles, if we found the largest, can either one of the other angles be obtuse? No, so it really doesn't matter. I'm just going to stick with the smallest one just for consistency. I want to find angle C. Sine of angle C over, 5 equals sine of 115 over 12. And then go ahead and see what angle C is. And then just do 180 after that. It really shouldn't matter which one you find first. So, Dominic, let me know what you get for angle C.
I got 22.2 degrees.
22.2. And so I got angle A, angle C, angle B is going to be 180 minus 115 minus 22.2. Clev, let me know what you get. 32.8? 42.8. 42.8. We agree? We good? All right. Get a couple of these done. I didn't give you a ton of examples, but those are the only two types that come up with law of cosine. Side angle side or all three sides.
Oh, here's some funny out. Yeah, the textbook is again I just don't put a lot of involved in the album. It's alright.
ESPN.
You can watch the other one. I'm just shutting down my video. Yep.
Oh no.
28.